In this video, you will learn how to solve two-step equations. When you solve any equation, you will always want to follow reverse order of operations, because what we're doing is we are undoing the different operations that are taking place. So to undo the different operations, we go backwards. So as a review, your order of operations is parentheses, exponents, multiply, divide, add, and subtract. So for example, if you had 5 times n minus 8 equals 72, to solve, I'm going to go backwards. So I'm going to begin with subtraction and addition, and then do multiplication and division, and then do exponents, then parentheses. So here we see subtraction. We see minus 8. So we begin with the minus 8, and our end goal, by the way, is to get this to look like n equals something. So n equals a number. So our objective is to get rid of both the 5 and the negative 8 so that n is by itself. So we begin with the subtraction because that is the last thing we normally do with order of operations. So to get rid of the minus 8, we do the opposite or inverse of subtracting 8, which would be adding 8. So we add 8 to both sides here and here. When I add 8 to the left side, negative 8 plus 8 would cancel, which gives me 0. So 5n plus 0, or just 5n. On the right side, we have 72 plus 8, which is going to equal 80. Now to finish off, this says 5 times 9 equals 80. That's with the 5 in front of the n, or sorry, 5 times n, not 9. 5 times n equals 80. So to get rid of the multiplication of the 5, I do the inverse, which would be division. So I divide both sides by 5. On the left side, the 5s would cancel, which gives me 1n, which is what I wanted. And on the right side, I have 80 divided by 5, which would be 16. So my solution is 16. And I can always double check by plugging the 16, or the number, back in place of my variable. So instead of 5 times n minus 8, I have 5 times 16 minus 8 equals 72. Is this a true statement? Well, 5 times 16 is 80, and 80 minus 8 would indeed equal 72. So my solution of 16 is correct. Next example, we have 1/2 x plus 4 equals 10. So once again, we are doing reverse order of operations. So we are going to begin with addition and subtraction, and then work our way up from there. So here we see plus 4. This is the first thing we need to take care of. So to get rid of the plus 4, I do the inverse operation, which would be subtract 4. So I subtract 4 from both sides. On the left side, the plus 4 and minus 4 would cancel, and that would give me plus 0, which is nothing, so we just have 1/2 x on the left, and then 10 minus 4 is 6 on the right. So from here, there's two ways to think of this with 1/2 times x. So one way is going to be that we, to get rid of the multiplication, must do the inverse, which would be division. So we can think of this as dividing by a 1/2, and then over here, divide by a 1/2 as well. 1/2 divided by 1/2 would cancel out, and that leaves me with 1x. So I have 1x on the left side, and on the right side, we have 6 divided by 1/2. Well, remember, when I divide fractions, that is the same thing as multiplying by the reciprocal. So instead of dividing by 1 over 2, that is the same thing as multiplying by 2 over 1. So we have 6 times 2 over 1, which is the same thing as 6 times 2, which would equal 12. So my solution would be 12. So that is one way to think of it. The other way is we can kind of skip over the step of dividing by 1 over 2, and we do that by simply multiplying by the reciprocal, because we know division is the same thing as multiplying by the reciprocal. So what I could also do is, instead of multiplying or dividing by 1 over 2, I'd be multiplying by 2 over 1 on both sides. And that has the same exact effect, because on the left side, 2 over 1 times 1 over 2, that would cancel. The 2's would cancel, give me 1 over 1. So we have 1 times 1 over 1 times 1, which is 1. So we have 1x on this left side. And on the right side, once again, we have the 2 over 1 times 6, which, as we stated, would equal 12. So either way, the answer is 12. But the second way I showed you would be a little bit quicker as we progress in this course. Example 3, we have w minus 4 over 9 equals 3. So to solve, we do reverse order of operations. All right, so we are going to begin with addition, subtraction, and then multiply, divide, and then exponents, and then parentheses. Now be careful with this one, because we see the minus 4, and the temptation is going to be to add 4 to both sides. But remember that this fraction bar actually serves as a grouping symbol. So this fraction bar makes the top as a parentheses, like this is all together. And the bottom, the 9, is all together as well. All right, so I cannot just simply add 4, because that is like a parentheses up there. That is one quantity. So I do the parentheses last, because I'm doing reverse order of operations. So I begin actually with the 9. So to get rid of the 9, I do the opposite operation. So this is dividing by 9. So the opposite of dividing by 9 would be multiplying by 9. So I multiply both sides by 9, or 9 over 1, same thing, and the 9's would cancel. So the 9's will cancel out, which leaves me with w minus 4 on the left side, and then on the right side we have 3 times 9, which is 27. So now I can do the last step, which is get rid of this negative 4. So to get rid of the minus 4, I do the opposite of minus, which is going to be addition. So I'm going to add 4 to both sides, here and here. The minus 4 and plus 4 will cancel out, which gives me just 0. So I have w plus 0, or w, on the left side. On the right side, I have 27 plus 4, which is 31. So my solution is w equals 31. And I can double check this answer to make sure that it is correct by plugging it back in to the initial equation. So instead of w minus 4, I'd have 31 minus 4, and then divide that by 9 equals 3. So 31 minus 4 is 27. So 27 over 9 equals 3. That is a true statement, so therefore 31 is the correct answer. Last example, we are now going to put this all together, where we need to set up the equation first with a given problem, and then from there we'll solve it. So example 4, Jeremy has $178 parked in $20 bills and 58 in other bills. And the question is, how many 20s does he have? So when you set up any equation, the first thing you want to do is determine what is your unknown value. So what are we trying to find? Well, we're trying to find how many 20s does he have. So your unknown value is the number of 20s. So from there we can assign our variables. So we'll let the number of 20s be our variable, and we'll call that x. So x would equal the number of 20s. So from here, we need to establish our equation. So we know that we have $20 bills. So if we have the $20 bills, we add that with the other bills, And that's going to give me my total. Right? So we can plug in numbers from here. The total is $178. The other bills was $58. And here, this is the trickier part. We need to determine how to write this. So we have $20 bills. So let's say he had like one $20 bill. This would be $20 because 1 times 20. If we had two $20 bills, this would be 40 because 2 times 20 gives me 40. So we take $20 times the number of 20s that we have. So times that by x, which x was the number of 20s. So we have 20 times x plus 58 equals 178. And the 20 times x, we could write that as 20x. So here's my equation. And then from here, we need to solve this equation. So to solve, as we stated, we go in reverse order of operations. So we start with addition and subtraction first. So we see the plus 58. We do the opposite of adding 58, which is going to be subtracting 58. So we subtract 58 from both sides. 58 minus 58 would cancel. So I have 20x on the left, 178 minus 58, or 120 on the right. And then lastly, we need to get rid of the 20. So this says 20 times x. So the 20 is being multiplied with x. So to get rid of the multiplication, I do the inverse, which would be division. So I divide both sides by 20. When I do that, 20 divided by 20 will cancel. That gives me 1x on the left. And then on the right, 120 divided by 20 would give me 6. So my solution is x equals 6. And now let's put this back into context. What did we just find? Well, what we found was the number of 20s, because x was the number of 20s. So my answer is that Jeremy would have 6 $20 bills.